Hello, everybody. This is Skip Elsheimer. Welcome to our lunchtime streaming show. Having a lot of technical problems today, including there's probably, because I'm using Zoom, but not using Zoom, there's probably a lip sync issue. But that's just the least of our problems. There's a website that I use to propagate my stream to YouTube and to Facebook and to Twitch and to Twitter. And it didn't work today, so that's what we're stuck with. But I'm still moving ahead and very proud and excited to welcome a longtime friend of mine, Tim Flaherty. Tim, say hello.
Hi, guys. I'm not showing up there.
Not showing up where?
Oh, well, unless I'm looking at the YouTube stream too. And
all right, so dude, you used to be on the radio.
Yes.
And so you should know, don't listen to the radio while you're talking on the radio because there's a delay.
Oh, I know this. I have it muted, so there you have it.
Okay, but still, there's still a delay. There's a lag there.
Yes.
So Tim, we go back quite a ways, at least to the 90s, maybe before.
It was probably late '89.
Okay.
Maybe early '90.
Right.
Somewhere around there. It was right after I moved back to Raleigh.
Yes.
From Wilmington.
Yes. And so you knew me before I started collecting films.
Yes.
And you knew me because of the band I was in.
Correct.
The Beatles, with an extra S on the end. And you used to do a radio show called Smash Hits, which was on the University channel.
That's correct.
NC State 88.1 WKNC. And because of that, and you also helped run a club called The Garage.
Correct.
And because of that, you were tangentially involved in many shenanigans that we did over the years.
Some of which probably shouldn't be mentioned in,
Yeah. I got it. I got it. But anyways, you were definitely there the whole time. You saw it happen. When films would mysteriously show up on my porch at my archive, I pretty much knew who was dropping them off. It was you.
I gave you some Super 8 and some 8mm and a couple 16mm films.
Yeah, I feel like a projector, maybe an editor. When stuff would show up, I kind of had a good idea who dropped it off. Thank you for that.
Hey, no problem.
So the reason I have you on the show, not only are we longtime friends, but I was noticing that you were doing a dance party, a daily dance party on your Facebook page.
Correct. And Instagram, those are...
Yes. And you would use kind of like the background that you have now, right? You would have a variety of different backgrounds.
Yes, and what I would do there is instead of doing a green screen like I'm doing right now with the collards, I actually would project your show onto a projection screen, which is actually to my left here, and I would project it and dance in front of that. And the mirror ball, and this is Judy H. They're always involved,
right?
But and I pretty much started because out of boredom.
Yes.
Being stuck at home, the whole quarantine thing, and so I was trying to do something just to be stupid. And then you started doing your videos, and I said, oh, I need to project Skip's video on my background. So that was probably after I don't know, when did you start? Because I started doing the thing early March, I think.
I started mid-March, like the 14th.
So it was like 15th. Shortly after I did that, I started projecting yours.
Yeah. So when you did the dance party, would you play music?
Yes, and I have my own streaming music server. I had a bad habit of collecting CDs, and I guess it's not a bad habit. It just I did. I would collect CDs and I would just encode them. And I just sometime back in 2004, I set up a streaming media server to stream my music out to the internet. And I just play that stream. So
Right.
I don't really have any control over what I dance to. I just try to dance about 1 o'clock. Usually I'd be setting up to dance right now. And then I would dance for about 15, 20 minutes to whatever happened to come on. And then I'd edit it down to 30, 40 seconds and then put that out on the internets.
So have you had a problem with the Facebook copyright hammer or the Instagram copyright hammer?
Yes. However, what I do is as soon as it pops up after I pop the thing and says your video has been muted, I click restore audio and I say this is fair use because I'm not actually playing the music for the music. The music is for the dance. So the dance is the focus. The only one that actually came back later and said, no, they weren't, still don't allow me to do it, were the Misfits.
Really? Oh, Glenn Danzig.
That was the only one. Everyone else is like, oh, okay. And like immediately it comes back in. The audio comes back in.
That's funny. All right. I could try that, I guess. I don't know. There's such a weird delay, and since I'm streaming to so many different services, it's hard to keep track on who brings the hammer down. So I try to, if I hear something that I recognize, I mute it.
Yes, and what the problem is you're doing a live stream. I'm doing stuff after the fact, so I notice it right after I post it, and then I put in my little appeal, and that's when it comes back.
Okay, interesting. And who is that just barked?
That's my dog, Hutch. Hutch, you want to come over here and say hi? Yeah. There's Hutch.
And somebody just got your joke of the greens screen.
Yes, it's colored greens.
Yeah, so good. Hi, Hutch. So the fact that you've been doing this, how many dance parties have you done so far?
Today will be my 196th.
Okay, nice. Since
last March.
Nice.
I only do it on days that I have to work, which is kind of bad, actually, if you think about it. So like, if it's a holiday or a weekend, I'm not doing it. So,
right. Okay.
Or if I have a meeting, occasionally like I'll have a meeting that there's no way I can do it for work.
So the main reason that I was like, you know what, I really need to talk to Tim is because of an image that you posted on your Facebook feed at some point. Let me see if I can summon it.
It was 3 weeks ago. 4 weeks ago.
Okay. So it was of your bandaged fingers.
Yes.
Let's see if I can collect. Moving images in OBS is kind of a pain. All right. So I saw that and I was like, huh, what happened? As did most of your friends. And basically, let me see. Let me bring this up. Okay. Then you showed an image of what you said was the other guy. And folks out in the internet, this is it's graphic, but it's not of his body. It's of his blood, but here's the other guy. So get ready, everybody put down your slices of pizza. What is this? Is it a belt sander?
It's a belt sander.
So Tim, tell me exactly what happened here.
Julia, my lovely wife, and I are remodeling our laundry room, and I went to I bought a piece of old bowling alley lane, which I was refinishing into a countertop. And so I was sanding it down with a belt sander, and I needed to change the belt. And not even thinking, I didn't unplug the belt sander. When I went and released the latch on the side of the belt sander to release the belt, I hit the trigger with my other hand. It grabbed my right hand and pulled it right in the belt sander.
So,
And I actually thought I was going to lose, and the people in the ER thought I was going to lose the top half of my right ring finger.
and thankfully, that's not been the case so far, correct?
That is correct. The hand surgeon, when he looked at it, he said, "Oh, there's enough bone there. I'll just wrap it up. It should come back." Who knew? Your fingers will actually grow back if there's enough bone there.
Ah, that's good. It's like you're like your fingernail.
Exactly.
Nice.
And now this is kind of disgusting, so somebody might want to hold their ears. The fingernail for the finger wrapped around to the other side, and they pushed it back over on top. So he said that will come back too.
Ah!
I am sorry about that. I hope I gave it a warning.
So what you did, if we were going to use avgeeks terminology, and people in the comments have already jumped on this, is that you shook hands with danger.
Exactly. But I didn't get to be Three-Fingered Joe.
Well, thank God for that. And in fact, if that had happened, if it was a situation where you did actually lose a finger, I would have felt very awkward about this. And I know this is so exploitive. I feel bad. I don't
like
feel bad.
being exploited.
Yeah.
You've known me for how many years?
Yeah, yes. And in fact, I did a zine where we talked about injuries, and you went at length about this amazing story about why you should take Advil with water. Was it Advil?
Never dry swallow pills.
Yeah, never dry swallow pills.
That was a lesson I learned earlier in my life, right after I met you, as a matter of fact.
Yes. And so I know that you will take an injury and you will use it as an opportunity to teach, as a teachable moment. And so that I appreciate about
Hey, no problem.
But I gotta wonder, like, so after you did that, did you hear the don 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 from Shake Hands with Danger in?
I actually right after I did it, no, because I was too busy prying my finger out with a screwdriver.
Oh yeah. Let me share that image real quick.
On the way to the ER, yes, and it was kind of funny because there was nobody in the ER when we went. And we were in and out of the ER with x-rays and everything in an hour and a half.
That's amazing. I mean, you live really close to the hospital,
like,
so.
I could have walked if I really wanted to.
Right. All right, there's the bloody screwdriver. So, I'd like to take this opportunity to play the Shake Hands with Danger theme that my wife had commissioned.
This is it right there, by the way, my finger.
Oh, wow, look at that. Yeah, it's looking pretty good.
Oh, you can't tell because it's still bandaged.
Yeah, of course. No, but, you know, it's not as, you know, you don't have a splint there and all that stuff. No. And so, all right, so I'm going to play the Shake Hands with Danger song, and if you would like to dance along, you're more than welcome to. All right.
Oh, I shall.
All right. And we'll get a sense, the people who are watching this will get a sense of what your dance time party show is like.
Okay.
All right.
I'll try to dance right now.
All right, sweet.
Well, I have to stand up.
Yeah.
Don't touch anything, okay? Get down from there! Now! Hey! Turn it over! What if it bumped that control by accident? You'd be mincemeat by now. What have I told you? You don't work on equipment when the engine's running.
Well, I told him not to touch anything. All right, I guess I wasn't thinking.
You weren't thinking? You mean you'll work on engines and machinery and not think of your own personal safety? Here, shake hands with Danger.
The worst part about this is that the laundry room's not done yet.
Okay.
I gotta wait till my finger heals before I can actually finish the laundry.
All right. Well, please heal.
I shall.
And we will see you again in Facebook world. Thanks again for your sacrifice. And
anything for you. Anything for the entertainment.
Great. All right, man. You take care.
All right. Thanks.
Bye-bye.
Bye-bye.
All right. Technology, man. Horrible. So frustrating. All right, so I really need that coffee. There's an opportunity to buy me coffee. Now's the time, because technology is just being a big pain. In the meantime, let's watch this film it's called the hand trap test, which is about the dangers that hands can face in the workplace.
To those who know better. It happens. Because just knowing is not enough. My name is Alan Edwards. In a moment, we will begin a test developed so you can find out for yourselves just how defensively you use your hands. How conscious you are of the many potential dangers threatening valuable and irreplaceable hands and fingers, everywhere and all the time. How aware you are of hand traps. To answer the test questions, just put a circle or check mark on your test form. Sufficient time has been allowed for you to give each question your attention and thought in order to arrive at the correct answers. Section A has to do with on-the-job accidents. Now, each question has 3 answers to choose from. Question 1. Each year in American industry, is the total of disabling on-the-job injuries to hands and fingers A, equal to the total of foot and toe injuries, or B, equal to the total of head and eye injuries, or C, greater than either head and eye or foot and toe injuries? I'll repeat. Question 1. Each year in American industry, is the total of disabling on-the-job injuries to hands and fingers A, equal to the total of foot and toe injuries, B, equal to the total of head and eye injuries, C, greater than either head and eye or foot and toe injuries? Circle the letter you think is the correct one, A, B, or C. The correct answer to question 1 is C. In 1965, disabling injuries to feet and toes totaled 225,000, and to the head and eye totaled 190,000. In the same year, there were 485,000 disabling injuries to hands and fingers, 70,000 more than the total of the first 2 combined. Now, this is not always held true, but today, hard hats protect your head, safety glasses protect your eyes. Metatarsal safety shoes protect your feet. Hands are different. The very way you use them in your work means their protection cannot lie in safety apparel alone, but your alertness, your thinking defensively and working defensively has to do the rest. Question 2. How often would you say that disabling injuries to the hands and fingers occur in American industry? A, one every minute. B, one every hour. C, one every 8-hour shift. Again, question 2. How often would you say that disabling injuries to the hands and fingers occur in American industry? A, one every minute. B, one every hour. C, one every 8-hour shift. Circle A, B, or C to indicate your answer. A is the right answer. There is one hand and finger injury every minute of the day. There will be 20 new ones before this test is finished, and this does not include the many hand and finger injuries that occur off the job and in the home. Question 3 concerns how your hands and fingers can be injured. There are only 3 ways. The hand or fingers can strike against some object. The hand or fingers can be struck by some object. Or the hand or fingers can be caught between 2 objects. Question 3 then. Is the greatest number of hand and finger injuries caused when A, the hand or fingers strike against some object, B, the hand or fingers are struck by some object, or C, the hand or fingers are caught between 2 objects? Circle A, B, or C to indicate your answer. Answers A and B are wrong, even including burns, where it could be said that the hands or fingers strike against something hot or are struck by something hot. Far and away, the greatest number of hand and finger injuries is due to being caught between 2 objects. Answer C is correct. Now, there is a name for these places where hands or fingers can be injured by being caught between 2 objects. They are called pinch points. Now, Section B will test your knowledge of pinch points and your recognition of just how many different forms they can take. You will see 7 illustrations in which hands either are or are not in a pinch point. As each picture comes on, just circle yes on your test form if you think the hand or finger is in danger, no if it is not. But remember, pinch points are a part of just about everything we do. They are not dangerous by themselves. It is only when something gets caught in them that injuries happen. Therefore, circle yes only when a hand or finger is in danger of being caught in a pinch point. Are you ready? Question 4. Is a hand in a pinch point or not? Circle yes or no. Question 5. Question 6. Question 7. Question 8. Question 9. The last question in Section B. Yes or no? Now let's see how well you did. The answer to question 4 is no. Though this is a common pinch point and a common cause of injury, this man works defensively. He uses his hand hook. The answer to 5 is yes. There is a pinch point. It's a bad one. Question 6. Yes. That rail is just about to be pushed in place. And though a three-man job requires coordination, don't count on it. Work defensively. Question 7. Yes. With the tool rest set too far away from the grinding wheel, the chisel can be drawn down by the action of the wheel pulling the finger into the pinch point. Question 8. A definite yes. And most of us at one time or another have skinned a knuckle or two to prove it. The answer to 9. A yes. Another common situation, when a passenger slams the door closed without looking, and people always slam car doors. Last question. The answer is no. The pinch point is there, but by working defensively and by using the knuckle guards, the man's hand is out of danger. Every question with a yes answer comes from real life. These were real injuries to real people, and they ranged from the bad spraining of a real wrist to the amputation of 4 real fingers. In 5 out of 7 cases, a pinch point became a hand trap. What makes a hand trap? You do. I do. Because pinch points can harm neither hands nor fingers unless our hands or fingers are caught between the 2 objects involved. We let them get caught. We create hand traps, and we get hurt. Why? In most every case, the unexpected injury comes from an action we expect to happen. It comes when things do just exactly what we are trying to get them to do. But expected actions often bring unexpected results. I have a desk drawer that sometimes sticks, but there's something in it I have to show you. Now, I expect eventually it will open, even if I have to really put my back in it. I accomplished what I was trying to do, open the drawer, but something extra was added, a hand trap. Oh, yes. Here is what I wanted to show you. Now, none of you would reach in this drawer now. You'd know what to expect. In Section C, you'll have a chance to test yourselves on expecting the unexpected, on visualizing when the very thing you're trying to do can turn into a hand trap. You will watch the beginnings of several work jobs. You do not have to be familiar with the job to answer the questions. At a certain point, we will stop the action, so you may ask yourself, what is the unexpected I should expect? Just circle A, B, or C. Then we will see how the action turns out. Here is question number 11. Assume you are the man in the blue shirt. You and your partner are moving pieces of steel on a skid. You're really getting into the swing of it now. The pieces are doing just what you want them to. At this point, you reach for another piece. Now, what is the unexpected to expect? What can turn this into a hand trap? A, the piece will catch on something and refuse to move. B, it will move as the others have. C, it will roll over. Now let's see what does happen. Answer B is right. You expect the piece of steel to do what you were trying to make it do, move. What became unexpected was that there would be no time to get the hand out of the hand trap. Question 12. Imagine you are the miner on the right, and you are helping to place a roof support. Turn this into a hand trap. A, the jack will slip off the timber. B, C, the timber will be pushed into place. All right, let's see what... Answer C is correct. You expect the timber to push against the roof, but keep the fingers on the sides of the timber. recognize and avoid the pinch point between the timber and the roof. That turns into a hand trap. Question 13. You are a helper in the maintenance department when one of the 3 V-belts driving a ventilator fan fails. After locking out the power switch, you must manually rotate the fan pulley in order to get the first belt in place. What can turn this into a hand trap? A, the belt will slip off on your side. B, the belt will go too far and slip off on the other side. C, the belt will pull into place on the pulley. Circle A, B, or C. Well, let's see. Answer C is right. You expect the V-belt to pull into place on the pulley. That's just what you were trying to make it do. But when you put your hand where a pinch point may occur, better expect the rest of it too, that you have put yourself into a hand trap. If you not only know how to recognize pinch points, but can think ahead to the hand trap that might result, you have developed the habit of working defensively with your hands and fingers in whatever you are doing. In the final part of the test, you can rate yourself on your awareness of hand traps. Section D consists of a series of scenes of men at work. You will see no injuries, but watch them carefully. And for every hand trap you see, every time a hand or finger is in a pinch point and in danger, put a check mark on your test form. If you spotted all the hand traps, you should have 7 marks on your test form. Let's see what they were. The first is here. When re-railing a car, work defensively. Expect the unexpected. This man right now has his hand in a hand trap, and the car may drop at any moment. Hand trap 2. There are drift pins, spud wrenches, and other objects to line up openings in material. They're a lot more durable than fingers. Hand trap 3. Don't use your thumb to check the cutting ability of a tool. Use a piece of metal, wood, or paper. Work defensively. No hand trap here. This man knows that when you hold a part in your hand while using a screwdriver, it can be a hand trap, and he used the vise to avoid it. Hand trap 4. You don't throw a bull ring on the crane hook with one hand. You drop it on using both hands and holding the ring by its sides. Hand trap 5. With his fingers at the top and bottom of the blocking, those fingers could suddenly be holding up a lot of steel. Work defensively. Keep the fingers at the sides. Hand trap 6. This man doesn't even know where he has put his hand, and the operator may not notice either until it's too late. The 7th hand trap. You always should expect a wrench to slip. Don't improvise ways like this to keep it from slipping. That is the end of the hand trap test, which shows that knowing's not enough. The only way to be sure and keep our hands and fingers for ourselves is to work defensively. Just think pinch points, recognize pinch points, avoid pinch points. It will keep you out of hand traps.
Thank you, U.S. Steel, for that. Really. So they showed potential damage to hands in there, but the film itself has been beat to hell. You could tell by all the emulsion scratches, vertical scratches. But then there was one point where there was just like this break. It was super splicey, which tells me that somebody was rewinding it on something that was going very fast, and the film just exploded. It just fell into these little fragments that they were able to kind of piece together, but left out parts. So this was probably shown a lot in some sort of factory setting by someone who didn't know how to use their projector. So it's interesting. So films do tell a story beyond the story that they tell, the physical damage that happens. You can sometimes see, like yesterday, I think I showed Visiting Nurse, which had punches in the middle, so you could tell that the film had been misthreaded and was off, and basically the sprocketed wheel was tearing holes in it. Amy, thank you so much for the coffee. It was very much needed today. There was a lot of technology, and technology just misbehaving, just not acting the way that I had hoped that it would. So thank you for that. And thank you, everybody, for joining me on YouTube, because basically Restream.io, which is the company I use to propagate streams, just stopped responding. Was not taking any streams, and so I had to quickly just send it over to YouTube and send a link on Facebook. I am recording this, so I might try to send it out to other things later today. So I got a film queued up. This one is part of the Science Screen Digest, which was made by Allegro Films. And basically what they would do is they would do a short film, and then they would get sponsorship in different regions or areas. And so you get to see this little commercial at the beginning and the end of the film for somebody. There's been foundries, there's Ciba Geigy, which is a chemical factory, there's been power companies. Let's see who this was. I got this from South Carolina, so let's see if it was South Carolina related. Here's engineering, science reshapes the future car. And let's see how close they get to what the future car looks like. Will it look like an athletic shoe? I don't know. Let's see. It's supposed to start at some point. Oh, I have to start it. Oh, God. What a day.
South Carolina is beautiful, and South Carolina Electric and Gas is working to keep it that way while ensuring a ready supply of electricity for today's needs. We are using new technology in making electricity. We're improving the efficiency of our generating plants, and we're building ahead today to provide electricity for tomorrow. And now, South Carolina Electric and Gas presents the Science Screen Report.
The Science Screen Report. Developments in science, engineering, and medicine, which help solve the problems of modern life. What will tomorrow's car be like? No one can say precisely. Nevertheless, it is clear that the future car will be shaped by three major challenges. Improving productivity throughout the industry. Developing more fuel-efficient engines. And managing the car's environmental impact. This is a report on that ongoing research effort by engineering, science, and technology. Science reshapes the future car. The automotive industry faces a major problem in the 1980s. How to apply engineering science to better compete in the new global marketplace. New answers include computer-aided design, useful in the downsizing and downweighting of new models. This is a computer representation of a design's natural vibration pattern. Viewing it, designers can modify the structure or other factors to manage such motions. Another tool, thermography, maps patterns of energy transmission, including transmission of mechanical shocks, and so helps designers reduce impact forces in crashes. With the car's structure set, the stylist can begin. These experts work in clay to better visualize the shape's subtle details. They also employ a special computer system which translates the clay shape directly into paper drawings and blueprints, saving thousands of man-hours. The design prototypes then undergo wind tunnel tests to learn their aerodynamic properties. Drag on a car accounts for 1/3 of its energy use, so any reduction in drag will lead to decreases in fuel consumption. In this case, the design builds up too much turbulence behind the car, slowing it. The design will therefore be modified, rebuilt, and retested in the wind tunnel until the problem is under control. Materials experts are seeking strong, lightweight polymers, heavy-duty plastics for use in car components. In this test material, the thermoplastic polypropylene is combined with tiny graphite fibers for greater strength. In another test, an electron microscope is used to record the structure of a polyester resin, reinforced and lightened via a mass of tiny hollow glass bubbles. With structure, appearance, and materials set, testing of components can begin. Failures here will lead to redesign and retesting. If the new car has any weaknesses, they must be discovered now. A major problem throughout the industry is metal fatigue, failures of metal components due to stress. The challenge, to detect signs of potential failure.
Well, I think it's time we took some more measurements, Stan.
Okay, I'll turn on the voltage of the electron detector.
This apparatus may lead to a new solution. It detects electron emissions, minute amounts of electricity given off by areas showing fatigue. By measuring electron emissions, the instrument can help predict the lifetime of components. Such detectors may someday prove useful throughout the industry. A second challenge to automotive engineers is the need for fuel economy, driving more kilometers per liter of fuel. The familiar spark ignition engine continues to be refined. Combustion physics studies employing laser beams are one approach. The laser provides data on temperatures and atomic and molecular components in the combustion flame, aiding in research towards more complete combustion. Lasers are now a frequently used scientific tool. This laboratory makes its own specialized lasers. Lead, tin, sulfur, selenium, and tellurium are combined. The mixture is then heated until vaporized. Cooling, it condenses into a crystal, which will become the energy-focusing element of a specialized laser. A stratified charge engine is studied via laser beam and stop-motion photography through a quartz window. The stop-motion film reveals mixing of fuel spray and air prior to ignition. A stratified or layered fuel-air mixture, rich near the spark plug, leaner near the chamber walls, allows use of less fuel per cycle to produce combustion. One promising alternate power plant is the gas turbine engine. Such gas turbines can run on many fuels: kerosene, gasoline, diesel oil, alcohol, gasohol, or others. But because gas turbines run at extremely high temperatures, they call for special heat-resistant materials.
Okay, let's light off. Pre-mix flame is a nice uniform blue.
It looks very stable, too.
Yeah, the NOx emissions are all below standard at this point.
Research on electric vehicles employing lithium-sulfur cells or nickel oxide cells may someday lead to electric cars with greatly extended ranges. The automobile's environmental effects are a third challenge. In this lab, sophisticated recording instruments map sources of engine noise, a step towards quieter cars. Much current research focuses on engine emissions. Here, a diesel engine's emissions are analyzed via laser optics. But laboratory studies such as this one of exhaust emissions chemistry are not in themselves sufficient. For instance, conditions in the real atmosphere often vary greatly. For this reason, at locations where environmental problems may exist, field data is collected by experts to add to their understanding of emissions effects. This project focuses on emissions controls for tomorrow's engines. using catalytic systems similar to today's catalytic converters.
By passing an infrared beam through a thin catalyst disc, such as the one located in this vessel here, and as one switches there to a ratio.
That is to actually pick up what these species are under our fluctuating conditions from rich to lean.
Yeah, I think it will do that by passing.
Tests involve an electron energy loss spectrometer, which measures adherence of pollutant molecules to the surface layer of the catalyst. It does this by reflecting an electron beam off catalyst crystal surfaces. The amount of energy absorbed is related to the strength of the chemical bond. Microprocessors, tiny built-in computers, can now precisely regulate many fuel combustion factors and so reduce exhaust emissions. Sensors in the exhaust and engine allow the microprocessor to adjust the fuel-air mixture, so to maximize combustion and so minimize carbon monoxide and nitrogen oxide emissions. Future cars may employ several microprocessors to improve performance. The final test of any engineering effort is its impact on man. Here a test subject pedals in a controlled flow-through environment to learn what effects, if any, his body exhibits from suspected air pollutants. Once, stylists shaped tomorrow's cars largely as they chose. Now, engineers and automotive scientists set the limits on their designs. What will tomorrow's cars be like? Smaller, safer, lighter, made of new materials, more fuel efficient, but with fewer environmental impacts. Tomorrow's car, a vehicle for tomorrow's world.
The Science Screen Report has been presented by South Carolina Electric and Gas Company, the company that is providing for today's electric needs while planning ahead for the future.
Pretty hip intro and outro. We didn't actually get to see a whole lot of the future of the car except for the K car. Which I had a K car in the 90s. It was about 10 years old, and I paid $500 for it. And it was an odd car because it had a stick shift. It was manual transmission. It wasn't automatic transmission, which is good because it was horribly underpowered. It had square headlights, which meant that if I was driving behind somebody, they would think I was a cop, and so they would slow down. It was so frustrating. And that car was horrible. It basically, stuff started falling apart on it, all the plastic and everything. I mean, this was a Chrysler, please help us, we've gone bankrupt, and we're going to quickly crap out a car. It got me from point A to point B, but things started falling apart on it, like doors weren't opening, windows weren't being rolled down, the brake light would just come on all the time, and then eventually it just started overheating, and there was nothing I could do to fix it, and basically to fix it was going to cost far more than I paid for it, so buy a K car. Yeah, good times. Anyways, thanks guys for tuning in today and dealing with all the technical problems. Thanks for watching Tim Flaherty, a good friend of mine, and his cautionary tale of shaking hands with danger. I showed some gross photos, but believe me, I did not show the grossest photos that he sent me of his actual finger without the bandage on it. It was it was gross. Very gross. So, And I was going to play this and have him dance along, which he did a little bit, but we're going to go ahead and play this. This was commissioned by my wife, a local singer-songwriter, did a campaign. He was going to put out a record, and in exchange, he would write a song for you. So him and his bandmate did this remix, or this new, I would say it kind of came out. If it had come out in stylistically, it probably would have come out the same time as the song. So this is a, I don't know, Rocky Horror Picture Show, but it's a pretty great version of this if you haven't seen it, and I haven't shown it in a while. So here it is, Shake Hands with Danger, updated.
I can get back here in a minute, so don't touch anything, okay?
Get down from there! Now! Hey! Turn it over! What if it bumped that control by accident? You'd be mincemeat by now. What have I told you? You don't work on equipment when the engine's running.
Well, I told him not to touch anything. All right, I guess I wasn't thinking.
You weren't thinking? You mean you'll work on engines and machinery and not think of your own personal safety? Here. Shake hands with Danger.
Shake hands with Danger. Meet a man you ought to know. I used to laugh at safety. Now they call me Three-Fingered Joe. I was young and feisty, never did things by the book. Just let me get my toolbox and I'll take myself a look. I climbed up on a dozier with my mechanic's pride. Said, you can keep it running, friend, while I poke around inside. Shake hands with Danger, meet a guy you ought to know. I used to laugh at safety, now they call me Three-Fingered Joe. Although I learned a lesson, I forgot it soon enough. The nicks and burns and scratches showed the young ones I was tough. Till another morning I was grinding on some steel. My other hand got careless and fed my skin into the wheel. Shake hands with Danger, step right up and say hello. Grinding wheels and metal are what made me Three-Fingered Joe. I've seen mechanics burning, and I've seen them take a fall just to save themselves a minute. I've seen them lose it all. I've watched them courting trouble, seen them take a chance and lose. They get careless for a moment and spend a lifetime with the blues. Shake hands with outside. Shake hands with danger and some friends I used to know. Compared to them, I'm lucky to be just Three-Finger Joe.
So great. And besides it being a hip song, it is a cautionary tale. So don't forget, if you're working on heavy equipment, lock it out, unplug it, turn it off. Your hands are very important, and also incredibly fragile. So there's your lesson for today. Yeah, thanks everybody for tuning in. We'll see you tomorrow. Hopefully, Restream is going to behave, and I'll be able to be back on all the different services. What I might do is go ahead and just if I can get it to work, I'll try to rebroadcast what I've been recording this on Twitch and Twitter and all that stuff, so that it's out there. If not, well, we'll just kind of see what happens. Everybody take care, and we'll see you soon.